Topic 29. Radioactivity. Part 1. Radioactive radiation. Radioactivity or radioactive decay. Radioactivity is the emission or giving off of particles and rays from the nuclei of unstable atoms. This emission is spontaneous, happens by itself, random, cannot be controlled or predicted over space and time. There is background radiation all around us. This is produced naturally. There are three types of radiation or emissions: alpha particles, beta particles, and gamma rays. The radiation can be detected using a Geiger-Müller tube. Penetrative power of radiation. Alpha particles can be stopped by a piece of paper. Beta particles can be stopped by an aluminium sheet. Gamma rays can only be stopped by a thick lead slab. Ionizing power of radiation. Ionizing power is the ability to remove electrons from atoms to form positive ions. Firstly, alpha particle is simply helium nucleus. Helium atom without electrons has very high ionizing power. The biggest mass in charge of the three radiations, the biggest punch, can knock off electrons. Beta particle, moderate ionizing power, with a smaller mass in charge than the alpha particle. Characteristics of alpha particles. First of all, they are helium nuclei. The charge is 2 pluses. Travel at speeds of up to 10% of the speed of light. Highly ionizing due to frequent collisions with air molecules. Travel up to a few centimeters in air. Stopped by a thin sheet of paper. So alpha particles are least penetrating. So there are 5 bullet points. Memorize 2 or 3 of them at least. Characteristics of beta particles. Beta particles are high energy electrons given off by nuclei. So they come from the nuclei. Travel at speed up to about 90% of the speed of light. Not as ionizing as alpha particles. Can travel several meters in air. Stopped by a few millimeters of aluminium. Characteristics of gamma rays, not particles. High energy electromagnetic radiation. You already studied that. Travel at the speed of light. Less ionizing than beta particles. Stop only by many centimeters of lead. This is most penetrating. Effect of electric field on radiation. On alpha, it's this way. Alpha being positively charged, get drawn to the negative. Beta being negative, gets drawn to the positive. Gamma has no charge, just goes straight through. Effect of magnetic field on radiation. You have to use Fleming's left-hand rule to find out. Here we have magnetic field lines going into page, and gamma having no charge will go straight. Alpha gets deflected to the left, beta to the right.